Got some water here. Got the circuit. Giggity go.
Okay. So you can basically put the bulb into the water.
As when it's lit.
Yeah.
All right. Let me take off another bulb.
Because usually this will short out in regular electricity, and that's actually not very.
All right.
It's very.
So let's test this out. We got light, the holy light.
Yeah, and you can just put the bulb with the LED lids into the bulb into the water.
Oh wow! You see that? That's completely staying steady, submerged. And the other light is also on. The circuit's not even disrupted. And also, I'm recording this, so this is awesome proof.
Yeah, that's cold electricity. It's a lot. There's not a lot of people who have seen that before, so this is a good party trick.
Got it on lock.
Yep.
Straight to the AC. So, what else would you suggest I do?
I would suggest you could rectify with the full wave rectifier there. You could rectify the signal to a DC signal and wire up some regular extensions cord. Yeah.
All right, let's do that.
To the output.
Where the power is coming from perfectly, then I understand what to do with it.
What's nice about that experiment is that you can literally prove negative resistance. So if you show that to your professor, he probably, I don't know what.
Professor, dog, you're my professor.
Yeah, but you gotta show it to them and see how they react.
I'm telling you, I don't have a professor right now.
Okay.
No, I'm just saying. I'm just being logical. Let's. What should we test? Should we put this on something? What should we put this on? Light bulb.
Well, you don't need to wire it up at all. Do you have a DC light bulb there?
I think it's DC. It's 220 volt, 240.
That's AC.
Oh, okay. Never mind.
So you can wire up the bulb to the output and see how much you can light it up. Some bulbs won't light up at all because they are too demanding.
Yeah.
This is not a very high wattage.
Oh, nice.
How cool is that?
This one in water too.
Yeah, but try it in the water.
And
it didn't work.
It worked. No, it went in. I just didn't want to get too much of the components inside.
Yeah.
It went in, and I just submerged it to make sure that these nodes were under the water. It flickered a bit, but it didn't really affect it.
Yeah.
So I got this motor, and it's got a yellow one, so it's got like an on-off one, but I don't know how to do that.
Right? Yeah, you can wire it up and see what happens.
Fair. So what could I put on the? What if I made this coil? What if I put this coil?
Nah.
What do you think would be good with coils and pulsing? Like I was even thinking if a coil was around this. And
yeah. But what are you trying to achieve here? Yeah, I think
a stable field.
A stable field.
Like to amplify the field that's just naturally occurring.
Yeah, but what type of field? Because the electric field is something you have there, and you have a very small magnetic field. So the electric field is what causes the electricity to be cold, in the sense that it doesn't ruin your components. Yeah. So if you light up your bulbs with that type of electricity, it will never run out. They will never wear out. Think about that. Isn't that profound? Yeah. Never having to change your light bulbs. Because it doesn't run, it's the amperage that kills our electronics, our components.
So what DC should I connect to this?
What DC?
Yeah.
Well, you do. That's not so. Well, you could basically you could wire anything up, but the thing is that when you rectify the AC signal, something will happen, and you will have a voltage gain.
So what should I connect it to right now? Is all I'm saying. A light bulb?
Wire, just a regular wire.
So just short circuit it?
No, just leave the wire be. Leave it hanging. Yeah.
Should I put him to the multimeter?
Sure. Put the multimeter on the DC terminals on the full wave rectifier, and measure the DC voltage.
That's what it's on. Yeah, it's over 2,000, dog. It's not even registering on the 600.
Yeah. So the more wire you add, the more voltage you have. Yeah. Okay.
Useless. Absolutely useless. No value at all. I just know it's a lot, and I touch it, it goes down.
Yeah.
Back up.
That's the most inexpensive meter I've seen.
Okay, you're saying I should get a better one?
Yeah.
I will. I got this one, but I can't read it because I don't have the app right now. My phone's being funky. I just brought it back from Canada. I had some more in Canada. But...
Okay, cool.
Yeah, man, that was a good little session.
Okay, cool.
If there's anything else?
Nah. You should. That should be fine for now. I mean, you shouldn't be playing around with the transformers just yet. You should probably play around a little bit more with the
electricity.
Yeah, what I'm trying to say is that it's not that dangerous, but you can, to really get the high wattage, if you want to sustain a big load and create this massive over unity, you have to have a ground. If you don't have a ground, there is no possibility for creating over unity. So the grounding is very important. It's very misunderstood, and it's something that people often neglect. Yeah. So grounding is the oppositional force to the it's the amperage, basically. It's the oppositional force to the cold electricity. So you're generating cold electricity right now, and if you want regular electricity, you have to introduce a ground so you can get amperage. So that's how you do it.
That makes sense. That makes sense.
So there, yeah, that's. So basically, what I would do now is just to play around with the full wave rectifier and see if you can.
Now, isn't it?
Yeah, but it's probably healthier and
that's what I mean.
Yeah,
it's better, man.
Because that's what cold electricity is actually very good for you in the right frequencies. It creates charged water.
So how can we adjust that frequency? Like, how can we create devices where we can control what frequency it's happening at?
The cool thing about this device that you have there is that the relay is that it's automatically adjusting itself to the load, so you can actually create it just automatically adjusts to whatever load you put on it. So there's a whole science to this, and you have to understand the different concepts of impedances and resonance. You know how you calculate resonance, both series resonance and parallel resonance, and all that stuff is very important if you want to get it right. In addition to a regular ground, you need a ground too. So in essence, you don't want this to be the device that powers your house or anything.
Yeah.
You just want to demonstrate this because it's very hard to wire up MOSFETs and all that stuff for newbies. So it's better to start with this device, I figure, and then you can go from there. And it's more tangible when you have the buzzing, right? When you have the buzzing, you understand that there is vibrations on the line that is causing the excess energy. Because that's actually what you have now is actually a so-called over unity device. It's very close to unity, or yeah. So it's actually over unity. It's about 1 to 2 watts performance, 1.5, 1 hour, thereabouts.
That's awesome, bro. Okay, well, let's get back to it then. I'm gonna go. I need to do some other work, and I got a class soon.
Yeah.
And it was really nice talking with you today.
Yeah. Thank you.
How's the week been? Good?
Yeah. Actually, it's been a tough week for me because all the chainsaws that I have been broken down, so I have had a lot of struggle.
You had no chainsaws? You had to axe cut wood?
No. We use regular chainsaws. So I do forest cultivation. That's my work.
That sounds nice. It sounds fun.
So I have a lot of time for myself and to think about electricity and stuff.
I know the feeling.
Yeah. So basically, I'm trying to. I contacted the group called Fatigue. The special interest group on Facebook. They are. Have you heard about them?
No.
There's a group that Stefan was tipping me about. So I joined up with them, and yeah, I'm hoping to learn something from them pretty soon. And actually, there was a guy that was talking about anti-gravity platforms there just recently.
Interesting. That'd be nice.
Because you're into that, aren't you?
Hoverboards, bro.
Yeah. Yeah.
I'm like serious. That's all I care about. Like, I don't even want to make a car fly. I just want a hoverboard.
You want a hoverboard, right?
And I want it to be working at the same frequency as the magnetic frequency of Earth, the 7 hertz.
Well, that's basically like a bumblebee. They are resonating with the Earth's magnetosphere. So
is that why you want to name your company Bumblebee?
Technology, yeah. That's why the buzzer. It has defined all my research. That buzzer there. It's learned everything about electricity that I have come to understand. I don't know how many hours I've been playing around with that type of buzzer, but it's immense. I mean, from 1 year ago, I didn't understand this as good as I do now, but now I'm starting to really get the big picture, and it's pretty.
I know the feeling.
That's profound.
I'm just hoping that that'll happen for me every year. Like, I keep learning more, and I keep like getting it more, and then I just hope that continue that.
Well, anti-gravity isn't that hard, actually.
Exactly. Like,
but the problem is that you can also disappear. That's one of the problems with the anti-gravity platforms, is that if you are doing trial and errors, you can all of a sudden the resonance can get so high that you just go woof, and you just disappear from this this reality that we're currently in. That's something that has happened with the people who have been playing around with this type of technology. It just disappears, and they don't know where it goes, but it probably is another dimension or something like that. So it's very hard to, it's very weird. So, I mean, James Clerk Maxwell was the guy who basically made this the mathematics for our electricity today, and he said that there was 16 different types of electricity. I mean, so we don't really know how this universe works yet. There is still a lot to understand. Okay.
All right. I'll see you soon, bro.
We see. Yeah.